All right, well, we've got a big crowd, so that's good. Let's get this kicked off. All right, pull requests this week. We've got one new one that I saw. This is oh shoot, I didn't paste the title in this. Just 1 second. This is start a new MD log segment in the MDS. If new coming event possibly exceeds the expected segment size. Uh, so apparently, I think this helps in heavy load cases. And Patrick is looking at it. I think there needs to be. It looks like there's some testing that needs to be done on this unit test created for it. So that is being worked on. Yeah, and that is it for that one. We did have two PRs that closed. Sage implemented some optimization for GIL handling in the manager, basically thread contention stuff, block contention, I believe. We looked at that some last week, and he's trying to make. Was this that problem? No, this is a different one. Sorry. In any event, he's trying to get the manager to behave better in certain situations that he was running into. So we figured out some things last week when we were working on that. Let's see. Second one that closed, set min alloc size to optimal IO size. That was basically for devices that have a larger allocation size. Then this PR just tries to recognize that and set the min alloc size to be optimal for that device. We had a number of updated PRs this week, though. This TTL cache implementation, I think this is a new version of an older PR that does the same thing. Some tests were run. I think there was some more review that was done on that PR, and now it needs further updates. The WIP primary balancer PR from Josh Solomon. Laura reviewed this. I think there was just a couple of tweaks that need to be done for the docs. Laura, are you here? Do you remember that?
Yes. Yeah, so Josh is working on that right now, and we actually have a balancer meeting to talk about what's going on with that. So mainly it's a refactoring PR. So as opposed to refactor the existing code and not really add anything, but we're fixing the code so it's easier to read and that it's structured better. And then this is kind of the first step in a multi-step process of actually improving the performance of the balancer.
Cool. Sounds good. All right. Let's see what else. We've got more work. Oh, sorry. This PR from Radic about introducing huge page-based read buffers. Igor reviewed that. Igor, I think your comment was that you wanted more information about what this would be used for. Is that right?
Yeah, and some testing coverage as well.
Okay. Cool. Next, we've got BlueFS fine grain locking from Adam. I believe that was updated and new tests are being run on that. Is that right, Adam?
Now it seems to be in the green, but still first we will test incremental updates in BlueFS. So still one more round will be needed for that one.
Okay. Very good, though. Exciting. Let's see. Next, make sure blob FSCK much less RAM greedy. Igor, there's some more discussion on that. Instead of discussing that right now, let's discuss it after the PRs because I think we'll have a bigger discussion on that one. Moving on then, OSD optimized PG removal, also from Igor. That's gotten a little bit more discussion and updates. Igor, what's the status of that one? Is it passing tests, or were there other things?
Well, I still have one failing test, and now I probably understand the root cause, which is the fast removal, which impacts the state of the PG, and in this test case get some additional unexpected state of the objects in this partly removed. So, well, prior to this fast removal, the PG was it wasn't removed completely, and some remnants still exist, and hence there were no complaints during the further backfilling. And now with fast removal, G is able to be removed completely before the next stage, and the test case produces some additional errors, which probably might be ignored. But, well, I actually realized that it looks like PG removal procedure should be interruptible, and one might request to recover from PG under removal back to normal state, and this should be handled in the reclaim mode as well. So, well, hopefully I found the root cause for failing test case, but additionally I need to revise some behavior of this stuff. So still work in progress.
Okay. Well, good luck. Sounds good. All right. Next, PR, get rid of tcmalloc max total thread cache bytes environment variable and use a ceph.conf configuration value instead. Also, let's talk about this below because I think we'll have a bigger discussion on it. And then finally, another one from you, Igor, reducing memory footprint of some of our data structures. I wanted to just bring this one back into the limelight a little bit because there's been a lot of discussion lately about memory usage of the OSD again. And I was wondering, Igor, do you think this would be something that we can reasonably resurrect?
Well, honestly, I don't know. I'd prefer to get this fast removal and shared blob with a CK matched first before proceeding with this one. So,
okay.
I'm not sure I have enough resources to work on this as well in parallel.
Sure. All right.
So, well, probably we can set different priorities and, for example, say that this memory footprint reduction is of high priority. I don't know.
I suspect that you're right about the FSCK one being higher priority. The numbers that you showed were huge.
Yeah, and I saw at least a couple of cases where it hurt the users.
Yeah, and as much as the data structures shrinking them, if I remember right, it was only like a 10 or 15% gain, which is sizable, but it's not the dramatic, crazy gain that you saw with the FSCK fix.
Right.
All right, so in fact, since we're talking about that, let's move on to that topic. Unless anyone has any PRs that I missed. All right, then, let's talk about shared blob FSCK memory usage. Adam, you gave a review in the PR. Do you want to summarize your concerns?
Yes, I mean, basically, I might be wrong here, so I'm very glad Igor is today on the call. My worry is that new improved, less greedy, memory greedy FSCK procedure comes at some cost. I mean, I think it's now possible for some specific, although unlikely, cases of shared blobs errors to squeeze through FSCK procedure. And if that's the case, I'm not liking it very much. Except for that, I really think that that's a great work, and it showed like 3 times less memory usage for FSCK, reduction from 35 gigabytes into 11 gigabytes for a sizable 11 million shared blobs OSD. So that's nice. And basically, that's it.
Well, unfortunately, I'm a bit unprepared for this discussion, so I was planning to take a look later, and it was, well, a while ago when I submitted this PR, but as far as I remember, it doesn't provide false, well, it doesn't detect false errors, but in some cases, it could just at some stage, the first stage, it might get some shared blobs, presumably, which might get some blobs, still good blobs, to be marked as presumably broken. And on the next stage, this would require some additional verification.
Yep, I noticed that in really that PR in the when it detects there is an error, it repairs sometimes more shared blobs than it's necessary. But it doesn't actually change anything. They are just recreated the same. That part is okay. I'm perfectly okay with that. But if you're unprepared, then let's postpone it, because I'm thinking about the case when you have 2 shared blobs which point to the same bucket, but the error is that objects that do reference those shared blobs do not match with the shared blobs tracking info. So in total, like we have 2 reference counters from 2 objects, but referencing 1 shared blob, but both of those counters are split into 2 shared blobs. So it sums up to 0, which is okay, but still that's not correct state. So that's
that's potentially that's possible. So you might get some so you might get the state, well, theoretically, when errors in one object compensate errors in another one. But well, I tried to probability of this to a minimum, so that there is still a small chance of that, but it's well, it's very low. I would expect it to be very low. So yeah, that's like with usual checksums when you can compensate one error with another, but the question is the probability of this.
I mean, overall, if we can get FSCK done, that's infinitely better to pass, to let squeeze some errors than not being able to execute it due to memory limitations. So in that regard, I think that's overall an improvement.
One thing I want to note, all this discussion as we think about this at a high level, is that we have users that are running OSDs now in a container that has a 5 gigabyte container limit, and it will kill the OSD if it exceeds that. I don't like this, but apparently this is happening. So it is probably worth thinking. This is probably a fairly high priority thing that we need to figure out, especially even with Igor's PR. If we're in a situation where potentially you could be using more than that. It could be a kind of we might start seeing OSTs in containers like die on FSCK.
Yeah, and unfortunately, I couldn't find the algorithm which is reliably limited by the RAM. So this implementation still depends on the amount of shared blobs. So it consumes much less memory, but it's still dependent on the amount of shared blobs. So you can't limit the RAM consumption with a fixed value. Like 5 gigabytes. So if database contains more shared blobs, it would go above this threshold. And I saw Adam's comment on that, and the idea to shard this FSTK procedure and handle just a subset of shared blobs at each step. But unfortunately, that's not a general solution anyway. It still, so we should read every object, every shared blobs from the pool, and if the shared blobs are not spread equally between different pools, might still get the case when just one pool gets the majority of shared blobs, and it still goes above the memory limit. So, and you can't, well, at least I couldn't find the algorithm to shard these shared blobs belonging to a single pool.
Well, my proposal was much less sophisticated than that. I just thought about splitting, like when I got 10 millions of shared blobs, I was thinking if I can handle, just take blobs with IDs 0 to 3 million and make one run through all the objects. Just ignore any other shared blob because they should be disjointed sets. So I'm okay to just process a subset there. And after I finish that 3 million shared blobs, I will go another set. Possibly that would require me to fix one object multiple times if it has multiple shared blobs, but there was no limitation by size of pool or PG or collection.
Yeah, I got it. So brute force approach, you just trade RAM for, well, you just trade RAM consumption for number of iterations. Yeah, maybe that would work. Yeah, so I was trying to minimize the number of iterations over every object.
I think we have to do something like that to be able to have an upper boundary on the memory usage. It's unfortunately, I think, I mean, Josh or Nihal, you can chime in if you think differently, but given what we're seeing people do with containers, I think we need to figure out ways to avoid situations where we can where we cause out of memory crashes, essentially.
Yeah, I think in general, even outside of containers, it makes sense to try to stay within the memory target that we have configured, because in other circumstances, you might have a situation where, like, maybe a server fails, all the OSDs are starting up at once, and because it was unclean shutdown, they're all running FSCK. And that kind of situation, you could run into ORMs even without containers involved.
Sure, it's a very good point. So I guess do we need to do more than this PR then? I mean, is this something we need to get in for Quincy?
I
I
mean,
wouldn't say
I got
so Quincy, but I think we should try to address it. Yeah.
I'm somewhat nervous about the bug reports that we might start getting otherwise.
I guess the other side of it is how often does FSCK end up being run on a data set that's like on a data set that's large enough to cause so much memory growth.
Yeah, it wouldn't. I mean, the incidence of it might not be that often, but when it does happen, right, then people won't be able to restart their cluster or that OSD until they get more memory.
Well, they can restart, but they should disable FSCK. So there is still a workaround, which is disabling FSCK, but
And is this kind of memory usage only happen during the deep FSCK, or is it happen during the shallow one as well?
If I remember correctly, it happens during. So, well, right now we have 3 modes: shallow, regular, and deep. Honestly, I don't remember, but either starting from regular or maybe even in shallow mode. To double check. And actually,
in any case, it does not require deep to actually run into high memory usage.
Right. So
Okay.
deep differs from the regular one in a way that it reads object content, reads and verifies object content. It actually produces the same data structures, just more lengthy due to the need to read every object.
That memory allocation is visible in our current memory pool statistics, right?
Probably yes.
Yeah, I would think it should be mostly shared blobs.
Yeah, but the question is how to inspect that, since I believe OSD is not completely started at this point, so it doesn't respond to external commands.
Sure. It just blows up memory, and the only thing you can tell is that it got OM killed. That's unfortunate. All right. Anything else on this topic for now?
Just want to mention that actually depends on the usage patterns. So it looks like it might be some not best usage from users. So I mean, having that many shared blobs means something weird is happening with the cluster.
I have a question. Maybe you guys know how many shared blobs should we expect from an OSD hosting RBD pools?
I don't know, Adam. I might have known at one time. I think I remember vaguely looking at stuff like that, but I don't know that I ever really did any kind of deep investigation into it. it's probably not a bad idea to do another one.
Yeah, but well, as far as I remember, in the relevant ticket, I mentioned some numbers, and unfortunately, they were taken from the field. So they really had that many objects, or that many shared blobs. And they were getting like 27 gigabyte of RAM I used during FSCK.
Igor, do you remember what their workload was?
I don't. I
Okay.
probably can't. I probably can ask, but don't remember at the moment.
Well, basically, I'm able to recreate 10 million shared blobs pretty easily. It's just fill up some OSD with data, then make a snapshot, and then perform like random write for moderate amount of data, and I get 8 million already. So that's pretty quick producing test.
Oh boy.
Yeah, that's definitely pretty reproducible in artificial mode. I was initially hoping it's not that frequent in production and in real use cases, but it's still possible to meet.
All right, let's move on to the next topic here, since we've got a couple more to go through. All right, Adam, you mentioned that you wanted to talk about the PR that you made a little while ago to set the tcmalloc thread cache size as a configurable Ceph option instead of using the environment variable. Sage showed some interest in this recently because he wants to make a low memory configuration template, essentially, that would change the setting along with a bunch of other settings. So that's why I think there's renewed interest in this PR now.
Well, I can reiterate what I already told some time ago. Basically, I think that's just a clash of philosophies here. My thinking was that I would prefer to provide a toolkit to modify tcmalloc settings, and it should be just easy enough to apply it to any daemon. Just provide which configuration variables should be tracked, and hence any daemon could easily inherit that logic. And the other approach is just make it a generic part, and that's it. That's the end of topic. I would like to say, just let's decide which path we should take, and I will adapt the PR.
I wonder if we should have it in the perf glue. Let's see. So Adam, are you familiar with that? It's the code here that lets us kind of abstract away some of the memory allocator stuff.
Yes, I think I've seen that. Yep, I looked at that.
I don't know if the other daemons that use tcmalloc, if they use perf glue or not, I guess. But I guess the mon does and the OSD does. Casey, are you here? Does RGW? Well, actually, are you guys using tcmalloc now?
Hey, I think so. Pretty sure we are.
You are? Okay. Do you know if you're using perfect glue code so you can do like the heap profiles and heap stats and that kind of stuff?
Not that I know of.
Okay. It might not be a bad idea though. I don't think there's anything too major that we need to do that in RGW as well. Um, and then this Patrick's not here. I was going to ask if the MVS uses tcmalloc. I think it does.
Yeah, all the demons do, I believe, in this point.
Okay, good, good. So, I mean, it seems like this would be a good place for it, maybe, in the implementation for tcmalloc. I thought I remembered this being kind of an abstraction layer. Maybe, maybe Adam, we could add something into the heap profiler thing here to just set the thread cache, and then I know that for libcmalloc they have something similar where you can control that, and then we could abstract it if we ever go back to using libcmalloc again, which I don't know that we will, but then we'd have the option to.
But you now thinking about making that configurable common for all daemons.
Well, yeah, maybe if they include the perf glue, then that would be another mechanism they could then set that we could have abstracted away so that depending on the malloc implementation, it does something or doesn't. What do you think?
Well, I rate that as a specific decision for each daemon, because you say include something and then apply some action. Then I'm hearing there will be some library to manipulate tcmalloc or other allocator settings, but you have to use it. And I thought maybe the option B could be, not I am like proposing it actively, to make it a part of a global configuration and just enforce some global configurable common to each daemon. That will be my option B.
So wouldn't you just have a ceph.conf setting per daemon that would then call this thing? I guess that's what I was thinking. Call the whatever we name it in this. Am I thinking about this incorrectly?
Yeah, that could work that way. I mean, I might like it for as long as there is no defaults, because I don't believe defaults will work well in that case.
Adam, as I look at your code, you're already using stuff from the perf glue. Right? You're using Ceph heap set numeric property, which is already part of that code. So I guess right now you're already dependent on that being available anyway. So what you have right now in the Ceph OSD code, right here, I'll post it in the chat window. I'm proposing essentially that we just do that directly in the heap in the perf glue code instead of doing it in the OSD. Does that make sense?
Yep, I think that might be more reasonable.
Guys,
but then
is there any business in allowing any part of Ceph to not use tcmalloc? I'm pretty sure we are doing that for clients and unit tests. and at least in case of unit test, it brings some unwanted consequences. I faced a micro benchmark I did in discussion where the overhead of memory allocator was really important. Maintaining two variants of support for two memory allocators might be burdensome. Is there any good reason for not switching clients to TC?
Do we have, I mean, our clients, right? But we don't have
Exactly.
control over what other clients do, but our clients we
Of
could.
course.
Yeah. I can't think of any. Does anyone?
I think the concern around that was possibly around clients writing memory from a different allocator and then us trying to free it with TC-Malloc or something like that. Some sort of mix of allocator uses across the API boundary.
But Josh, I thought
Sure
that
that's
Radek was
actually
just
ever-
talking.
This
I
would
thought Radek
apply.
was. Oh, go ahead, Radek.
Sorry, it would apply for third-party applications linking with LibRados.
Right.
But what about the clients that are under control?
Yeah, I thought that Radek was meaning that when we compile like our own tests, that we do it with TC-Malloc, not like compiling. I guess like a user should liberados with it. Maybe I'm misunderstanding.
Yep, that
Yeah.
was the idea.
Okay, yeah, I don't see any reason why we can't do that.
Yeah, it seems like a good idea to me.
Well,
So
maybe this
go
would
ahead.
simplify the things.
Maybe. Adam, as I look at the code here in your PR, it looks like the counters are being set in the priority cache currently, but maybe we would. I mean, I'd like to have all of the daemons using the priority cache eventually, but they don't right now, and maybe it shouldn't be required for TC-Malloc third cache counters. What do you think?
I look at that PR and there is something missing. There is no actual listening for change for that variable, and that's not something I remember. I remember distinctly that I tested if it reacts on the fly for changes in TC-Malloc size. So I will find better PR because I'm thinking that's not the last one I made regarding that.
Oh, okay, sure. Okay. Does anyone have any opinion? Sage had mentioned putting this in global init. I wonder though if we should be. I still wonder if we should be doing most of it in perf glue. Does anyone have any strong opinions one way or the other?
My opinion is that giving a default, if that will be global, will be very difficult.
Sure. So if we set it in the perf glue, have that be where we interpret. Well, okay, I see what you mean. Although wouldn't the global, can't you set that on a per daemon basis then? You override the global default? That works,
I
right?
think so. I think so. It should work.
Yeah, so I mean, we don't need like the OSD memory thread cache bytes. We could just have memory thread cache bytes, and then have like, if you wanted to define that in global, you could, but you could also then override it on a per daemon basis, right?
correct, but what that default should be?
Right now it's 128 megabytes, right? That's what I think all of our environment variables are setting stuff to.
Okay, so I think the best approach would be me modifying that PR into another approach, global this time, and we will maybe reiterate discussion once it's done.
Sure. I think what I'm concerned about is I don't think we should do anything specific to TC-malloc and global in it itself. It should be handled through like the perf glue abstraction. That's my take on it.
I guess perfglue is already initialized through a global init, isn't it?
I don't remember where it's initialized, to be honest.
Okay, I will just poke around with the code and find some valid place to attach it.
Okay, cool. That's exciting. I think Sage will be happy because then his small memory config will be much easier to set up. All right, next, related conversation, kind of. Earlier this week, to the people at Red Hat, I gave a presentation on Crimson kind of Q3 status, and as part of that presentation, there was a brief discussion about memory fragmentation with different memory allocators. And earlier this week, Gabby had asked me about why that's the case, and so I thought it would be good. Well, actually, Gabby had recommended that maybe talk about it in the meeting here today. I linked a couple of things in the Etherpad here. There's a really good blog post about the whole topic that kind of gives an overview of why libc-malloc tends to fragment memory. And I just posted the same thing in the chat window. Gabby, did you get a chance to look at some of that?
Yeah, I did. It was very interesting. I didn't know all of that. I didn't realize how much multi-threading impact glibc-malloc.
Yeah, it sounds to me, just based on kind of the description of how it works, that you get to decide, do you want to have lock contention or do you want to have memory fragmentation? And you can do one or the other, but you don't get to eliminate both at the same time.
Yes, that's what my feeling was.
So yeah, I also, in the same section on the Etherpad, I linked a couple of different documents. One is just the Crimson presentation I gave earlier this week, and you can see kind of the higher memory usage with libc-malloc there. But then there's also another older test that we did from 2018 when RHEL decided to remove TC-malloc from the standard packages that they provide. We did some testing at that point as well with libc-malloc and saw also extremely high memory usage. So the gist of it is basically that it seems like maybe it's actually a little better than it used to be, but there's still a significant memory fragmentation with libc-malloc versus TC-malloc in the OSD. And in fact, just recently I found out that Gluster is moving to TC-malloc as well. They were doing some of their own tricks to try to reduce memory fragmentation with libc-malloc, and they found out that just getting rid of all of that and switching to TC-malloc was better than their own attempts to make libc do the right thing. So one thing I did want to mention in this is that even TC-malloc is not really 100% immune to what we're doing. When we load a lot of ONodes into memory for the ONode cache, typically what I see is that the OSD memory auto-tuning will kick into high gear and start shrinking the aggregate cache size to deal with fragmentation. So before, when we have a lot of data in the cache or we have a lot of RocksDB stuff in the cache, we tend to be able to have fairly close to the like a 3 gigabyte overall cache size. But once we start really loading lots and lots of O-nodes into memory, then typically that shrinks down to between 1 to 2 gigabytes, just to try to deal with it and keep the overall target size. If it has like the default 4 gigabyte, then keep the overall mapped memory size around that target. So this is still, improving our memory allocation patterns and kind of reducing the amount of transient objects that we have would probably help a lot. But that's kind of my takeaway from this. Gabby, any other thoughts or comments, or anyone?
I was just wondering, it seems that TC-malloc is much more concerns about memory size. Does it impact performance? Is it slower or faster than glibc-malloc?
Historically, it's also been faster.
Okay, so we get it. It's faster and consumes less space.
Yep. It was. I think Greg was the one that originally implemented it many, many years ago, and I seem to recall that it was a fairly big win at the time. Josh, you might remember better than I do. I think it was right around the time I joined.
Yeah, maybe earlier than that, but yeah, it was a significant reduction in memory usage even at the time it was introduced, and I think we still see that today, like as you saw in your test with CentOS or Rel Mark. And yeah, performance is, I think, was also pretty significantly better, although I think the effect there in performance was less drastic than memory usage overall.
Sure.
Another question, do we have any idea what's the overhead with TC-malloc, the memory size? So we did compare glibc to TC-malloc, and it seems to be factor of 3. But do we know what is the actual unused of internal fragmentations from TC-malloc? I'm sure we can get stat counters and such from them.
I don't know if we can easily get fragmentation stats counters out of TC-malloc. I don't remember seeing any. If maybe there are, but I think
we at least have the RSS like versus actual allocated heap, right? If that's something.
Yeah.
And
yeah.
Like the things memory that's not returned back to the system as well that kernel hasn't reclaimed in some cases.
Yeah, and I think that's actually the bigger problem, right? Is that you just don't know when if the kernel's not facing memory pressure, it may just not ever reclaim stuff. So it's a little misleading.
What do you mean reclaiming? I thought that TC-malloc is pushing it.
No, it can free memory, right? It can say, I no longer need this, I'm done with it. But the kernel may just decide, it's fine, I'm not under pressure to give anyone memory right. I'm just not going to bother reclaiming it.
So the kernel is buffering memory?
Well, the kernel may not reclaim it until it needs it. And it will still count as RSS memory for the process.
And we force the kernel to reclaim and then just take snapshot of the counters of the forced reclaim?
I don't think we can force the kernel to reclaim. I don't think there's any way to do that. I could be wrong, but that was my understanding the last time I looked at this.
So even under this assumption, do we know what's the difference between RSS and supposedly used memory?
Yeah, you can look at it, right? We've got counters for both, I think. I don't know if we do for RSS memory, actually. You might be able to out of the TC-malloc stats, though.
Yeah,
otherwise,
stats, but I'm not sure anywhere else. That's something we don't have great stats on today, but I think that was one of the things we were thinking about adding to the telemetry perf channel, so we could start gathering some data there.
Yeah.
So we have any idea if it's 10%, 20%, how many percentage?
Well, but it floats. It's not going to be a constant. It depends on whether or not. Yeah. From just anecdotally, I've seen it look really different depending on the operating system. On Ubuntu, it was higher than RHEL. It looked like on Ubuntu they've got kernel tunables such that maybe it's reclaiming less aggressively. I think on RHEL maybe it was more aggressive in the reclaim. I think it was like typically between like 10 and 20%.
Okay. So that's rule of thumb, 10-20% overhead.
Yeah, but like I said, it's somewhat variable. You can't. It's really, really dangerous to look at RSS and try to do any kind of like sizing based on it. I attempted that a couple of years ago, and it was awful. It caused all kinds of really, really wild swings in behavior because you'd be releasing memory, and the RSS value wouldn't change for maybe a minute, and you'd be thinking, okay, I need to keep releasing memory, free memory to make my RSS value go down. And it doesn't work that way. You can't really track it as a way to guess at how much memory you're using for real.
Yeah, I mean, but if 10-20%, it's not that bad when we consider glibc as having 200-300% overhead.
Yeah, exactly. And frankly, I don't know that. I mean, glibc probably has the same thing going on with RSS, if not worse, maybe.
I just wanted to chime in. I spent a lot of time with memory allocators in a past life. And I don't know what the libc allocator is based on today, but at least I want to say 5 years ago, it really was worse in every way than tcmalloc or jemalloc. I spent a lot of time in jemalloc, less so in tcmalloc. But the biggest difference from a fragmentation perspective is that the libc-malloc was actually unbounded from a fragmentation perspective. If you had the right pattern of allocation and deallocation, you could actually take up all of your memory with a very small amount of allocations because of the way that it did heap management. The tcmalloc and jemalloc essentially solves that problem by having size classes. You don't have unbounded fragmentation anymore. But the bane of all memory allocators is an allocation pattern where you allocate a whole bunch of small stuff and then free some of it. And you will always have fragmentation from that. Just the thing is with tcmalloc and jemalloc, your fragmentation will be bounded by your maximum allocation count, versus in libc-malloc, like I said, your fragmentation is actually unbounded.
I think that probably more or less explains why our OSDs are rough on memory allocators.
Yeah, well, and especially the pattern I just described is STL, right? Like STL does exactly that all the time.
Yep.
And we also prolong time of some objects versus another, which is caching in BlueStore, and we ready for fragmentation.
So strings growing with incremental growth, that's another problem. When you take a string and you add some stuff to it, it means you have to free the old one and get a new one, which is a little bit bigger.
Yeah, that's generally less of an issue in tcmalloc, jemalloc. One of the differences there is libc-malloc, at least traditionally, was better at being able to grow the string in place without needing to do a mem copy. But with size classes, whenever you hop between a size class, it forces a mem copy at the allocator level, essentially. But I mean, it was never guaranteed with the libc allocator in the first place that you wouldn't have to do a mem copy. So you always have to assume that that's going to happen. But yeah, you're right. Like that should not cause major fragmentation problems. That pattern.
Gabby, I think this is a really good story for working towards reusable objects, pre-allocated reusable objects.
I'm also curious about the C-star allocator. I know, I'm not sure how much folks have looked into this yet, but like C-star does its own allocation by pre-allocating everything up front and managing it all itself instead of relying on the kernel to reclaim anything. I don't know, Radek, if you've looked into the way it works at all.
Yep, I was taking a look, and it does, as you said, it allocates, it basically chunks the memory. The side effect, well, the limitation coming from it is the fact you can have only limited number of shards in Sister. No way to utilize more than 256 cores, if I recall correctly. But indeed, it's a very, very simple statical sharding. The only funny thing is its ability to deallocate from external core. That's all.
Anecdotally, using the C-star memory allocator for the stuff that can be used for in Crimson, with like Blue Store and Alien Store, it shows much better behavior than if we use libc for everything. So
and even TC, I think. Well, when I was switching from the classical to the sister world, I was amused how good how low overhead is related with the allocations in C-star. It's very fast.
Yes, Radek, how difficult do you think it would be to switch Alien Store and Blue Store in Crimson to use TC-Malloc rather than
I tried
libc-Malloc?
doing that, and no way, no easy way, because, well, there is the restriction of having the constant number of threads, constant and fixed, and there is no reusing of them, which stays in bright contrast to what RocksDB does internally during the start. At least during its startup, it creates a bunch, rather big bunch of threads, short-living threads, to be honest, but still, they deplete the number of shards. We would need to extend the sister allocator to make the sharding more dynamic, precisely to reclaim shards that are not longer used.
So how does it work right now, Radek, with the libc allocator being used for?
At the moment, it works in that way that the sister allocator is responsible for serving the sister world, but it passes through all requests from Alien world, particularly from Booster.
And why? Sorry, I'm slow with this, but why is it that we can't do the same thing with TC-Malloc? What's the difference between libc-Malloc and TC-Malloc in this context?
Not sure. I'm not sure. I think we got a misunderstanding. I initially understood you want to replace the libc-Malloc we use at the moment in alienized Bluester with the sister allocator. Not.
Oh no! I mean,
sorry.
Just for the Bluester part, can we use TC-Malloc? But
I think so. I think so. Yeah.
Oh, okay. Do you think it would be difficult to do?
Hopefully not.
Yes, that's my impression too. Okay. I think it would give us a pretty big win for Alien Store and Blue Store if we could.
We should try.
Yeah. Okay. Let's see. We are at the end of the hour. I had at least one other thing on here, but it'd probably be a big discussion. So maybe we push it off for next week. That's the OD sync write performance. I guess, does anyone have anything else they want to quick discuss this week, or should we be done? All right. Well, then next week maybe we'll talk about this OD sync rate performance topic that I wanted to bring up, and I think Josh, you had also mentioned kind of more general Ceph performance topics. So we'll push those off for next week. Does that sound good?
Sounds good to me. Thanks.
All right, great. Well, then have a great week, everyone. See you next week.
Thank you.
Thank you, guys.
See you soon.
Bye.
Bye.
Bye.